recap because I just started the recording. We today are learning about compounding periods and compounding interest. Simple interest compounds just based on the time in years. Compound interest, we use that same formula, but T becomes the number of compounding periods in a year. And compound interest is different from simple interest. Simple interest, you only earn or pay interest on the principal or that beginning amount. But compound interest means that you're going to pay money on the principal or pay interest on the principal or earn money on the principal, but you're also, over time, earning money or paying more for interest. So you're paying on, earning or paying on the principal plus the previous interest earned. Annual compounding means that it's compounded once a year, and that's what simple interest is. Semi-annual compounding. So we've used these terms before. Semi-annual means how many times a year? Semi to interest compounded twice per year. And you'll notice now that we're twice per year is every 6 months. So it's going to be 0.5 is your compounding period. 0.5 would be your T if they tell you it's compounding semi-annually. So what this means is you can't figure the interest over time if it's compounded more than once a year, just one time. You'd have to figure it in increments of time. Quarterly, 4 quarters in $1. Quarterly compounding means it's compounded 4 times in a year. That would be every 3 months, 3 months out of a year. Or you could think of 0.25 is the same as 25 cents, right? That's a quarter. Quarterly compounding, our T is going to be 0.25. Daily compounding means it's going to be compounded 365 times because there's 365 days in a year except a leap year. And then it's going to be compounded 366 times. And yes, they do adjust for that, whether you have to pay the interest or whether you're earning the interest. On leap years, you pay 1 day more, or you pay 1 day, or you earn 1 day more. I want to remind you or caution you, we're not going to round 1/365. Anytime we use that daily compounding fraction of 1/365, we're just going to enter that in the calculator like that. Okay? We're not going to round it. Y'all caught up with me? Nope? Okay. You'll have time to come back if you're not quite done. I'll remind you that some will start by and I'll come back to it. Most people are done. Okay, so we're going to use that, what looks like a simple, and is the simple interest formula. If we invest $1,000 in one at 2% rate, how much interest would we earn in 1 year, and then what would be the new balance? So we're going to identify the parts we need to plug into the formula. We've worked with this formula before. The principal is that beginning amount. The rate we turn into a decimal. Remember how you do that. Divide it by 100 and get rid of the percent symbol. And if it says compounded annually, we have to know that means that our T is 1. So we're doing 2 things. How much interest would we pay at the end of the year, and then what would be the new balance? So our interest, we're plugging in 1,000 for P, 0.02 for R, and 1 for T, just like we outlined here. And then we're going to put that in the calculator. This is not one that's that big a deal for you to do this on the Decimus calculator, but $20. So that is A, how much interest would it earn in 1 1 year. And then B, the new balance, remember, is your principal plus the interest. Always make sure that you're answering both parts of the question. On the computer, it's a little bit easier, a little bit more obvious, but at paper pencil test, you got to be careful. All right, we're going to move on. Let me know if you need me to come back in a minute. Now we're talking about a deposit of $1,000 in a savings account, and they pay 2% interest. Same amount of principal, same interest rate, but now it's compounded semi-annually. So it's compounded every half year. Our interest, all they ask us to do is find her balance after 1 year, but we're going to find her interest in order to find her new balance. The principal, same as the last one. The rate, same as last one. But now the time, semi-annual, that T is going to be 0.5. We have to compute the interest at 6 months. And then we'll have to compute the interest at the second 6-month period, the second compounding period. So just plug in. So for our first compounding period, we're going to use the principal that these numbers that we identified. And then Marie would earn $10 after the first year. To find our new balance. Sorry, not after the first year, after 6 months. So now, but we want our balance after 1 year, right? So now we've got to use this new principal. We're going to use a formula just like this. So this is compounding period 1. That was our principal 1 here. Now we've got to use a different value for the principal because she has a different amount that she's earning interest on now. She's earning interest on the principal plus the $10 in interest. So everything else stays the same except for her principal. She now has $1,010 in her account, so they have to pay her interest on the interest they already paid her. So if you plug in everything else the same, this second compounding period of the year, she actually earns $10.10 in interest. And so now our new balance starts with her balance at the beginning of that second compounding period, added up, and so now it's $1,020.10. So this doesn't seem like a lot, but we have learned, or are starting to learn, I hope, that over time, that growth is exponential. So right now it's only 10 cents, but if she would leave that money in there for 30 years, that increased number of compounding periods would make a big difference in her total value of this deposit. So there's 2 compounding periods in a semi-annual. So we have to find the new balance after each compounding period. All right, y'all caught up with me? Alrighty. This question says, how much does $1,000 earn in 3 months at an interest rate of 2% compounded quarterly? What is the balance after 3 months? Well, 3 months is that. So if it's compounded quarterly, it is compounded every 3 months. There are 4 3-month periods in a year, right? So there's 12 months, so every 3 months it would compound. So we're going to start by identifying our interest, our identifying our rate. It's actually the same as the other two examples. But now it's compounded quarterly. We have to remember that that's the 0.25 time period. T is actually the compounding period unless it's just compounding annually, right? And then, or if it's simple interest. Okay, so we're going to plug in. We want to know how much she earns in interest, and then what is the balance after 3 months. So we're still plugging to the I equals PRT. I equals PRT. You find that after 3 months is up, she actually earns $5 in interest, and so her new balance after 3 months is $1,005. Does not mean she would earn $5 in interest for the next quarter, right? She's going to earn a little bit more than that because she would be earning interest now on this new, bigger principal. Any questions? All right, moving on. How much interest does $1,000 earn in 1 day at an interest rate of 2% compounded daily? And what is the balance after a day? So once again, identifying the parts that we're going to plug into the formula. These are all the same, but compounded daily, remember that the T is always a part of a year that you're compounding. So if you're compounding daily, it's 1 out of 365. So now we're going to plug that into our formula and see that it'll earn 5 cents, about 5 cents after the first day. You'll notice that this is not rounded here. Do not round this. The Desmos calculator I'm going to show you is very easy to enter this. We're not going to round. We're not going to take 1 divided by 365 and round it and then plug it in this formula. We're going to enter this from left to right just like that on the calculator. The Desmos calculator makes it super easy. So once y'all get it written, we're going to go over there. I'm going to show you how easy it is. When you round, makes a difference. Makes a difference in your accuracy. We're always going to, since we have always can use a calculator in this class, we're never going to round in the middle of a problem from here on out. All right, we're always going to plug in the fraction or whatever they give us and then round at the very end. So let's look at this one on the Desmos calculator. Right, I'm going to clear all. So it's 1,000. If you guys want to do it with me, you can. Times 0.02. Times, now we can do the fraction, AB, 1 and 365. So we don't have to do any rounding. This is way easier, right? You can also use this when we're going to do a problem. We're going to do compounding, multiple compounding periods and find the balance after a period of time. If you do it here, you can see each step what you've got to work with. So we would round this for my guys who are rounding challenged still. If we're rounding to the nearest cent, that second decimal place to the right, that 5 is what we're rounding to. So the two options are it stays at 5 or it goes up to a 6. Those are the only two options. Look to the right. That number 4 is less than 5, so we would drop all of this and say that it's about 5 cents, 0.05. Okay. So that's how much interest they earn after 1 day. The balance after 1 day is $1,000.05. You always, if they ask for the balance after a period of time, you take that balance and add it to the interest. And make a note, it would not be 5 cents a day. Each day it's going to go up a little bit. And by the end of the year, that compounding daily, it's a pretty big amount of growth. It's exponential, right? We've been talking about exponential growth. Compounding daily is how you get that, or compounding how you get that exponential growth. Aldrin, you following along with this, bud? You all caught up? Okay, great. Okay. How much interest does $4,500 earn in 3 months at an interest rate of 1.05% compounded quarterly? So the first thing we're going to do is find out how much interest, identify how much interest is earned in the first compounding period, because that's quarterly, 3 months. Okay? What is the balance after 1 year? So we're going to have to compute the balance 4 times to get that. So we're going to start by identifying our parts that we're plugging into the formula. The principal we know, hopefully at this point, is 4,500. The interest rate, divide by 100, lose the percent sign. The shortcut is to move the decimal point 2 places to the left. At this point, though, if you don't know that shortcut, the easiest thing to remember is just divide it by 100 on your calculator. It's easy, easy. So the rate as a decimal is 0.0105. And then if it's being compounded quarterly, it's being compounded 4 times, it's 0.25. It's being compounded every 3 months. So for the first 3 months interest, and to find the balance after a year, we have to always start with the first compounding period, find its interest. Pretty straightforward, 4,500 times the rate times that quarterly compounding. And so we're rounding to the 1. That's less than 5, so we're going to drop all that off. It's 1181 in interest. So that's our first answer, right? So that answers this question. Now we've got to find the balance after 1 year. To find the balance after 1 year, we're going to start by finding the balance at each compounding period. So quarter 1, the balance at the end of quarter 1, the balance is going to be $4,511. Make it bigger so you can see it back there. $4,511.81. So now we've got to compute the interest and the balance at the end of each compounding period. So we're going to go over here to our calculator. I'm going to clear that one. 1,000 times 0.0105, I believe, times 0.25. No, is that right? No. Oh, 4,500. Forgot we switched that. Okay, you see how easy that is to see that you entered something incorrectly too? It stays in there. You don't have to scroll over. The arrow doesn't move over anything. All right, so that's the amount of interest in the first compounding period. Add that. And now we know this is our new balance for that second quarter. So I'm looking here. Now I use this ending balance for the quarter as my new principal. So this goes here. And now we do the same thing. We compute our interest. And if you're using that Desmos calculator, you can see it all there. And you, in theory, wouldn't even have to write it down, except if you want me to give you partial credit, I need to see what you're putting in the calculator. I'm going to let you all write it down, then I'm going to pop over and put it in the Desmos calculator. All right, so I can already see my previous balance, $4,500. 451181, and I can see what I put in that top one. I don't even have to go back to a screen. Is times 0.0105. We can even copy it. Let's just copy and paste that. I mean, it's crazy how easy it is to do on this calculator, just like you're working in Word or something, right? So now I can see I've earned interest on the second quarter. It's going to be 1184. So I'm going to take this balance, 4511.81. I'm going to add the 1184 that I've rounded that to the penny. And now this is going to be my beginning principal for my third quarter, my third compounding period. So that's where this number comes from. So we're going to add that 1184 to the 4511, but your calculator will do all of that for you if you'll practice using it. So plus 4511.81, that's 4523.65, right? And that's where we get this number. Looks like a lot of work, but if you use this Desmos calculator, it's crazy how much work it takes away from you. Once you write this on your paper and then enter that in your calculator, if you know how many times you're compounding it, it makes it a lot easier. Now, there are computers that do this. You just enter it in, enter all our information, of course. And we're going to learn those formulas, too. You don't have to do this by hand. Right now, this is the only way we know how to do it. We are going to learn some other things that will help us. So now for the fourth quarter, we're going to take, the third quarter. So where do you do that one? Yeah, third quarter multiplied by 0.005. I'm going to go back here. Did you guys write this already? Okay, so let's go back to our calculator. So now I'm starting with, I don't even have to type it. I can copy and paste it. I can copy and paste this. There's no danger of me doing something different. Look how stupid easy that is, right? So now I know that my interest on this quarter, I'm going to round to the 7, so it's going to be 1187. So I'm going to take that previous balance, 4523.65, and I'm adding 1187. Right? So that's what we have here. So now that we've added 1187 to this amount, I'm giving you way too much detail, but I don't want to be there any confusion. So this plus 4535, oh, wrong one. So we've got our new balance here. So now we're going to take this and add it to the 4523.65, which I think we already did on our other screen, and see that it's 4535.52. This is our last quarter. We're going to multiply it by this again, come up with the interest, and add it one more time. We are going to learn a formula that will do this. We won't have to do each the quarter or the compounding period, but just so you know, this is the process. That is how compounding interest works. I'll let you go ahead and write the whole thing there, and then I'm going to show you again on Desmos. That's a little bit. So if it's compounding quarterly, the interest has to be computed 4 times for every year you do it. If you wanted to do it for 2 years, you do this exact same thing 4 more times. We're not in here yet. We're not through that yet. We're on this. Yeah. Yeah, it's going to be 37,000. Right. We'll talk about that in a minute. Put your worksheet away right now. I need you concentrating on your notes, okay? But yes, the comma's in the wrong spot on the first problem on your worksheet. That's what Miguel's pointing out. Okay. Let's go back over here. I know this is what I'm going to start with. I'm going to paste it. I'm going to copy and paste multiplying by all this. And now I know that that is my interest, 1190. Is it going to stay 1190 or is it going to go up to 1191? Is it going to stay at 1190, Evans, or is it going to go up to 1191? 1, that's right. So we're going to take that 45, 35, 52, and we're going to add 1191. And so the final value of that investment after 1 year compounded quarterly at that rate is 45, 47, 43. You see how much information this calculator will hold, how much easier it can make things for you. All right, any questions on that one? Yes, no? Okay. Oh, that's it. All right, so we're going to scan and submit, and then you can work on your worksheet or your 7.1 Nearpod. To where? The last one?